Skrbowski, in his talk, gave a very interesting analogy that I think is very useful. He's talking about why peak oil might be a lot sooner than people perhaps, it's fashionable to blame the economists, but the economists might think, and that's the seesaw analogy. On one side, we've got the countries that are expanding production, that's Angola and Kazakhstan and Brazil and all these places where more oil is being discovered, more oil is being produced. On the other side of the seesaw, there's the countries where oil production is declining. We saw the United States one. Bass Strait's been declining since 1985, Australia since 2000, the North Sea, and for instance, all these, Alaska, all these things going down. So we've got this seesaw balancing. And just because someone finds a bit more oil somewhere, it doesn't say that the seesaw is not going to be out of balance. And when, up till now, the expanding side has been greater than, or probably now equal to, the declining side, and it doesn't take much to tip it into a tipping point where a decline of production is happening more frequently, and then once that seesaw tips, then that's peak oil. The basis behind that is the discovery rate, that most of the world's oil was discovered quite a long time ago, a peak of production, discovery trend in roughly the 1960s, and it's been going down ever since. The black line is the consumption production curve. Since the mid-80s, then the world's been consuming more oil every year than it discovered, and that's getting down to, depending on the wiggles on the graph, 3, 4, 5, 6 times as much used every year than's been discovered. This graph is largely from ASPO, but it's been used by ExxonMobil, by Harry Longwell, in a slightly different form as well. In terms of peak exports, Jeff Rubin, an economist from the Canadian Imperial Banking Corporation, gave a paper at ASPO in Ireland about the internal consumption in the oil-producing countries. The graph on the bottom, the bottom left, shows the rate of growth of consumption in some countries. In Kuwait, Saudi Arabia, 4% growth in production annual in consumption internally. And the more they use internally, the less they've got available for export. So that the oil-producing countries are using, the rate of increase is much higher. And in part, on the top right, that's because of they're subsidising petrol. People like Venezuela, Iran, Saudi Arabia, Libya, Kuwait, all subsidise petrol, as does Queensland, incidentally. But Venezuela sells petrol at 2 cents a litre. So that doesn't really encourage people to use little cars or to think about it, and 10 cents a litre in Iran and Libya and things. So there's a very good case that there might be less oil on the open market of peak exports quite soon. And this is graphed by someone from ASPO Netherlands. He's graphing the oil on the export market, and that's been wiggling around. It had looked like it was going down, but there's a bit of an upturn. So it's a plateau there, but that might happen quite soon. And Rubin was forecasting a 4% decline perhaps relatively soon. What do the oil professionals in Australia think? I went to the major oil conference in 2005. API is the Australian Petroleum Production Exploration Association, the main lobby group, professional body. There were 1,700 registrants. And Eric Streitberg, who's a very successful CEO of an Australian oil company, doing very well, very small in a world way, but quite big. The advantage was he's the boss, he's in Perth, he isn't beholden to people in Houston or in Amsterdam or in London as the BP and the ExxonMobil and these things are. He can offer his opinions as he sees fit. And he ran a straw poll. How many people think we've crossed the hub at peak oil? Roughly a third. A third put out their hand, said they didn't. A third thought they were undecided, and he was a bit rude to the people undecided, saying you should go to management courses, learn to make decisions. But in fact, being undecided about peak oil, whether we're at peak now or it's later, is quite a rational point of view. One of the problems that a lot of people face is the magnitude. Australia uses a lot of oil. This is a graphic of it. Most of it's used in transport. If we took all of our wheat crop and turned it into ethanol, we'd only get some 9-10% of our usage, but there'd be no wheat to export to the people who need it overseas. There'd be no bread in Woolies. It's not very practical, and the same logic applies for hydrogen and electric cars and all these things. It's a very big amount. 100 mils of oil like this of petrol has got enough energy to move one car up to the top of the Eiffel Tower. It's very valuable. This is, 13 cents or whatever it is worth of petrol would save you carrying a car or pulling up on a rope or whatever to the top of the Eiffel Tower. It's valuable stuff. On the global scene, we're of course very small. China uses a lot more, and the US uses a cubic kilometre. It's a bit hard to superimpose that on top of the Sydney Harbour Bridge. It gets a bit small. But we're talking about really big amounts. Australia's consumption in the red line has been growing, whereas in Britain oil consumption's been flat more or less since 1988, since Margaret Thatcher put Britain on the fuel tax escalator. Discoveries and production started in Western Australia, then in the Bass Strait. Bass Strait started declining in 85. The peak in Australia's production was in 2000 there. The Howard government chose that particular point as their baseline for the energy policy, which is a bit iffy. And the forecasts are from Geoscience Australia. That's their 50% probability. So there's a big gap. We're looking at quite a lot of money, 12.5 billion, and if we import twice as much and the price is 3 times as much, that starts to be a really serious impact on our balance of payments. Roger Bezdek did a study, a very famous study for the US Department of Energy, was here, gave a talk in the Defence Department and at Parliament House in June, did some simple economic modelling of what you have to do to get around the mitigation things, using the technologies that are available, enhanced oil recovery, coal to liquids, heavy oil, gas to liquids, more efficient vehicles. Even if you have a crash program, a Manhattan project, high priority, really high funding, starting now, nothing happens for 4 or 5 years, and it takes some 20 years before you get any significant amount. This is on a world scale. So you have to start about 20 years beforehand with a very highly funded crash program. Neither of those are very likely. The probability of both of them is not very large at all. And he did this graphically, saying that there was an asymmetry in the cost. If you start the mitigation adaptation too early, for instance, you put railway lines and public transport and things, there's not much chance. But if you put them in a little bit too early, it might cost a bit. If you put them in too late, it's like building the ark underwater. The costs rise exponentially. And Minister McTiernan, Alana McTiernan, WA's Minister for Planning and Infrastructure, has said in 2004, the cost of preparing too early for peak oil is nowhere near the cost of not being ready on time. That's the same as Bezdek's asymmetric graph there. The impact of people on Sydney, part of the Oil Vulnerability Research Network, with a bit of luck, is that Griffith University, Dodson and SIPE have graphed things for Australian cities. The people in the outer suburbs are more vulnerable to rising petrol prices and things, and you can graph these. This is all from ABS census data. It's a first approximation. We could do a lot better, but it just illustrates that that even within one city, the risks are not uniformly shared. The ASPO oil graph is here. It's much the same, just showing a trend they're suggesting, perhaps 2010. The blue bit down the bottom is the conventional oil, the sort of ordinary oil that most people are using, the stuff you can pump out of the ground. The brown is the heavy oil, the tar sands from Canada, heavy oil from Venezuela. That goes out for a long time because you can't produce it in a hell of a hurry. It's very slow. It's more a mining thing. The blue is the very deep water oil, which is promising now, but was likely to tail off. And the green is the natural gas liquids, which are very important to Australia. That's condensates from natural gas. So that depends largely on the natural gas production. We've been doing some comparisons of the economists. ABARES oil forecasts have been systematically low. The blue is the actual price, and the other coloured lines are what ABARE said was going to happen. I heard ABARE talk about forecasters droop. They were talking about the geologists being wrong. ABARE have got a pretty bad case of that. We've got a random number generator that'll do as well. And there's a couple of economists suggesting 2 years ago that oil is going to be $35 a barrel, but the Nobel Prize winner says, no worries, ABARES, ASPO's and peak oil's all baloney, we've got it all wrong, it's going to be $15 a barrel in the near future. That's 2.5 years ago. I begin to wonder about whether the economists are on the same page or on the same planet, or we could say that they're on it from a different planet and they'd be much better if they stayed there.